Hi everyone, my name is Nahuel Garbezza and I will talk about a web console to control nanosatellites, which is a project I did at 10 Pines. I worked there. So before starting, a little bit of context. We did this project for Satellogic, which is builds nanosatellites using open hardware and software technologies. They launched a nanosatellite in April this year, and they are going to launch a new nanosatellite soon. So what we did was a console for them to interact with the satellites and sending commands, see what is coming from the satellite, and something visual. So, okay, what we did was the console part, which is written in Faro 2 and Seaside 3. The console is connected to a radio via TCP using sockets, and the radio is connected to the satellite. So we are going to see some of the key aspects we consider that were interesting of the project. The first one is discover what was the domain, also what is in a satellite, what we need to represent, to model, and we did test during development from the beginning because it helped us to gain a little bit of understanding incrementally. So it was very, very helpful for us. So a lot of concepts and some patterns emerged. So I will going to show you some classes. I will not go into many details, but I would like to show some of the most important classes. So I couldn't replicate the screen, so I will look there too. Thanks. So sorry about the. Not.
También hacerse con el micrófono.
Well, this is the model package. The first object we identified was the satellite. The satellite has a name, has a list of subsystems. Subsystems are represented by objects, which has our subsystem has a name and a set of command definitions. And the command definitions this represents the commands you can send to the satellite. So a command definition knows the subsystem which it belongs to, a description of the signature, the name of the command, the parameters if needed, and some return type if any. So this is one of the important things, what the detail of the types of every parameter and the return value. We build a hierarchy of types. Those types are defined for the commands. The commands are serialized into bytes that goes into the the stream that goes, the radio can handle and send to the satellite. And well, we have array types, enum types, integer types, a lot of variants of integers, some string types. A very important one, which is the struct type, which you can use to build more complex type, composing the simple one, or even structs. Another important one is the type converter that allows you to make explicit a conversion to one type, to one value to another by using a smalltalk block, and the void type for commands that returns void. Another important concept in the domain is the packages that the satellite can receive. Sorry, the package that the satellite sends and the console receive. The satellite knows the collection of packages that it were receiving, and there is many kind of packages. The beacon packages. Beacons are packages that the satellite sends every minute without sending any commands. The satellite is sending constantly those packages with a summary of the information of the subsystems and some kind of values. Well, they can be valid or invalid depending on transmission errors and that. It can be an invalid package, which is a package that you have received and you cannot identify. It can be a response of a script. This is something that I will be showing later. It's a special package. It's not exactly a package, but a response of a script. I will talk about the script later. The response to commands that you have sent are represented by the send command call response. They can be invalid, they can be lost, they can be a response of an unsent command. This is some weird case we thought about and we modeled. Is the case that the console receives a package that is because it has the shape of a response to a command, but you have not sent from the console. It can be from elsewhere. And the valid response. So this is the hierarchy we built. We tested all this stuff. We have a lot of tests. This is not just the model test, the test for all the packages. So I'm running them. There are some slow tests because of something that I would like to show at the end regarding the script stuff. But we have near 500 tests. Most of them are from the classes I mentioned, the model. Regarding the test, I would like to show a specific, an interesting test, which is the visitor test. Two of the hierarchies I shown before, the hierarchy of the data types and the hierarchy of the responses of the packages, are implemented using the visitor patterns. So any operation you need to do with those kind of objects, you can use visitor to define that behavior. And what the tests do is to ensure that the visitor is implemented correctly. So if a new type is added to the hierarchy, and if a new kind of package is added to the packages hierarchy. One of those tests, of the visitor test, will fail. So I will not explain too much details of that because I would like to continue. Well, the next things I would like to show is the visual stuff. Is a web interface we built using Seaside and a lot of jQuery and Ajax and JavaScript, but we tried to use Smalltalk to translate to JavaScript. Seaside was very helpful for that cases. And we needed to integrate with a jQuery plugin called Data Tables. It's a plugin for showing kind of complex tables with dynamic loading of rows and those stuff. So I will show you a demo of the console running. This is not connected to the real satellite, but it's just an emulator, I think. I have a yes. I will run the radio. The radio is listening for the satellite emulator and for the console. I will start an emulator, all of this stuff on my local machine, an emulator of the satellite. And we can go to the console. This is the console. It has the name of the satellite and some configurations we are going to see later. It has the table I mentioned, which shows all the packages that the satellite received. It has a panel on the bottom for sending commands. I'm going to connect it now. This panel to the right it shows the detail of the package you select on the table. If you don't select any package, it will show you the last one. So now I'm connected with the satellite emulator, and there is some packages coming from the satellite, and I can send commands. So as you can see, the look and feel is not very. We are not designers. So if you need to send a command, you need to specify the subsystem. So I have configured one satellite with some test subsystem. I have some autocomplete for the. So let's choose a simple command called version. The version command of the platform subsystem, and as you can see, the response just arrived at the top of the table. I can stop the refresh to analyze the packages. The table is refreshing every second. I can filter the table also and search for the packages I want to show. So this is the view for a response of a command. The one that I sent before. One thing to mark is that every send of command has a sequence number. A sequence number indicates it's a way to map a package that comes from the satellite and the command you send to match them and see if there is the package you receive is correct. And the sequence number is a number that is increasing by 1 when you send a command, or you can set it manually if you want. You can configure any other parameters, such as the number of retries. By default is one. Try to send one command. But if you put more, a higher number, it will try to send the same command the times you specify. There is a response timeout that can be configured too. In this case, it's 2 seconds, but it can be configured. So this is the summary of the view. No, it's not. It's not one. The next thing I would like to show is another requirement that was asked for us to do, was to display some timeline charts of the values you receive from the packages, beacons or response, to display them in a timeline chart. We use another JavaScript library, which is called HighStock, and we used we could write all the bindings with the smalltalks. It was not so difficult. So I have another image to show with not test data, but a real data, which is more interesting. Thanks, Richie. I will start the image. This is another image, another console configured with another satellite, which has more interesting things to see. So let's refresh the page. I will show you the screen you have seen in the next slides. This a different satellite with a lot of responses. For instance, if I choose a beacon, it is not connected, but I would like to show you only the chart.
I am the customer. I think it's interesting for you to know that this image is an image that I saved during the development of the satellite, and it was connected to the satellite while it was here in the ground. Now this one is in Russia waiting to be launched, and all this data is from the tests we were doing. And it's real data, and it's data that it was very useful to us, especially I think it's going to show the power consumption. We ran each experiment, and then using the console we saw the graph on how much power each part of the satellite used, so we can predict if the battery was going to be enough or not. It's going to be enough. So it's all real data.
So I can choose from the interface which values I would like to put in a chart. I can choose one of many of them. And this is the chart. It has a timeline. You can select the piece of time you want to see. It has some outliers, so I would like to show a significant part of the chart. So it shows all the values you selected on the detailed screen, and this is showing the
current consumption in 3 different voltages. inside the satellite. The 12, the blue one that changes a lot, it's because we were turning on the radio and off. So that's when the radio was booting, and then when the radio was working, and then when we turn it off again.
So this is the chart. But an important thing that Richie said is that he saved the image and gave that to us, and we can continue using them. We can start and run the console again, and all this information is in the image. Okay. I'll continue. The next thing I would like to show is another important requirement on the project, which was how those command definition you have seen.
Sorry, could you use some examples of command definitions?
I think it's going to be the next slide.
Okay.
Yes, we are going to. I just sent one in the console, but there are more commands there. So the code that is running in the satellite is written in C. So the command definitions are in C files, and the way we use to have those command definitions in Smalltalk is by implementing a parser using the tool Petit Parser. And we didn't use a generic C parser. We build a parser for those specific files. So, for instance, this is a C file that has some command definitions. This is from a subsystem called CDH, which is command and data handling, and all those statements you see here are definitions of commands. From that lines and another files needed, with all those information you can build a command definition and use it from the console.
For example, there's get radio configuration, set radio configuration, change the baud rate of the radio, transmit a frame, compute the MD5 of something, get the telemetry of the radio, that's the temperature and how many packets it received, change the power of the radio, and some test commands. We have other commands to turn on and off different parts of the satellites and operate. Whatever we need to do is via satellites. And we also provide very low-level commands that we use in ground for testing. So we have a battery of tests that test the satellite via commands. So it does very small things and then gathers results to see.
But we are talking about tens, hundreds, thousands of commands?
Around 500, I would say, and that's around 300, 200 most.
One interesting thing is that commands are defined in a way that then it's easier for the user to set it as a small command. That are you going to show how to set a command more complex or not?
I will show you.
We wanted to define the commands in just one place. And we wanted to be in the C files because that's what the developer does. But we choose a syntax, that's the declare command macro, that's very easy to parse. And it actually has information that's not used in C. It's only there for the small talk.
Like for example, times :U16, that is a parameter that is called times, that is a unsigned 16-bit, blah blah blah, and that is used to
Those information is mapped to the types in the Smalltalk image. So I will show you. I would like to go directly to just the web configuration. the satellite can be configured, and the configuration is related to the name and a directory of where those definitions are, and a file to indicate the ID of the commands, all the subsystems, and the information of the types, of the data types. So this is from this is not from the local image. So if I try to generate those configurations, it will fail because I don't have those files.
That's for my computer.
Home? Yeah. So it can be configured dynamically, and if you can test the configuration, if it is run okay, it will show you how many commands did the tool parse, and you can see if it's anything wrong with that. So this is regarding the configuration of setting. And the next important thing, I think one of the most of the key features of the project is it's a way to define more complex commands, not just the commands which we have just seen, that they are like primitives, right? So the idea is to use those commands to build more complex ones. So as the console users know Smalltalk, we let them write scripts using Smalltalk. So we build a way to define a script using some kind of metaprogramming to have a very concise and clear with a clear syntax to run. I have a very simple example for that. I will go back to the local image, so I can show it running. So I am with the first image. We have a screen to configure scripts. So I define a very simple script that if you edit them, you can define a name using a signature very similar to a Smalltalk method definition. It can have arguments or not, and it can belong to a subsystem. And there is a special subsystem called scripts. So what it does, well, it doesn't show the variable names, but the script is very simple. I know if it makes sense in the domain, but it will serve as an example. Is sending a command. This is a Smalltalk expression for sending a command. Just send the message thermal. Thermal, remember, it is a subsystem name to an object that represents a satellite, in this case for the scripting. And this expression returns an object that represents the thermal subsystem. And we send the command, the message status. All those messages, subsystem name and command names, as they can change, they are not implemented, all of them. They are all sent dynamically. This returns what it returns is the response of the command. The response is a value that you can query the values that they send. For instance, this command returns a struct. So for accessing the struct, you can use the field names. Now, again with dynamic message sending to get the values of the result. So we took an average and we compared to some argument that we receive. You can see if the console is running, I will connect again to the satellite. So now, one very important thing is that scripts are treated like commands. So in the panel, you can send us as a command. I choose the subsystem name, a special subsystem for scripts called scripts, and I can send here the script you have seen. I will pass it some number, and I will send it like a command. It's very fast because it's local. It's there. There is the response of the script that is shown like a package, and it will show all the packages that were auxiliary to the definition of the script. Let's see how this is implemented, which is, I think it's interesting. All the scripts that you define are mapped to a classes. So a script, a new class generated with a generated name, and the code you see in the panel. I can show you from there too. The code that you see here, it's mapped to a method called value. So let's go to the image. This is the class that was generated, and here is in the value the generated code. And when we run a script, this class is instantiated with all the necessary arguments. For instance, this satellite object is something that we inherit from the basic satellite script structure, and this is a proxy that defines the does not understand method to look for the subsystem in the satellite, and then is the same for the subsystem proxy to receive the command names. And the parameters of the script are mapped to instance variables. So when you send a command, it's like a message sent to a proxy that knows how to instantiate this object with all the necessary information. So I know if I have much time, I think it's. So we have seen how to create and edit some scripts and some technical details. And as a conclusion, it was a very interesting opportunity to work with Smalltalk on a real project, and in the personal side to gain experience on test-driven development, object design, and web development, which was a huge part of the project, all the JavaScript stuff and that. I would like to thank to Hernan, who was working with me in the project, helping me with some design decisions and that, and Gera Richie, which was our contact with Satellogic, and he provided us a lot of feedback and crazy ideas to implement. So that's it. Thank you for listening. If you have some questions. Do you want this? Do you want this?
It sounds anyway, whatever. 2 minutes for questions.
May I ask a question?
No. Okay. No, he doesn't know that.
I don't know, 2 questions. One is the commands send arguments or receive arguments that are measures. So the question is, are the units implicit or explicit? Second question, because I have only 2 minutes. I didn't understand why you need a class for every script.
So for the first question, they are implicit, the measures. They are just modeled as numbers, as I think. And for the second question, we thought it was interesting to model that because they can version the scripts using Monticello and they can share the definitions, and we thought it was the best way to do that.
The units are, there are no units. We didn't ask for that. The units usually put the name of the slots. The name of the slots usually include the unit. So it's like uptime _ MS.
Microsoft.
Yes. That's the name of the argument or the name of the key of the value that comes out from the server. We put it as the names. There are no knowledge of units.
You know, it's written in C.
No. It doesn't matter. It's, I think it's, there is a word in there.
Yes.
At the beginning we thought about it, but we decided not to make anything special because... Yeah, of course. I mean, you could add that information if you wanted it. No, but I think in the command declaration you could define not only the type but also the unit.
I'm learning from them.
For some, we do not have already formulas. So it is already, there is already mechanism.
Can I ask?
So, question.
Did you implement some kind of syntax correction by verifying the syntax of the scripting, or you just delegated it?
No, we let them do anything. I think they can break the image in a script definition.
Okay. So you're counting for the client to know also to do it.
Yeah, that's fine.
Okay.
But that's what we want.
No, okay, yes. That's good.
And I have a question. You also develop Ruby applications, web applications.
It's hard to say that, but yes.
So how do you compare both situations?
Be careful.
And answer correctly. Your boss. No, I'm just curious to know what you think.
No, to be fair, I would like to implement this on Ruby, so the domain can be the same, but I can take some conclusions, mostly on the web part. I use Ruby and Rails on another project, so I think the JavaScript part and all the jQuery and calls, asynchronous calls to the server and how to handle those kind of callbacks, it's something that I remember. I'm sure there are a lot of more advantages, but the most important I can think right now is that one.
What? I don't understand. What is better? Which one is better?
No, this one. Seaside, no, Seaside is the best.
Yeah.